We talked about binary and molecular a little bit before. So since we already discussed naming molecular compounds, the molecular ones, remember we said no, mo. And so the molecular ones are made of what? Non-metals. Awesome. These are made of non-metals. And next, we're going to discuss ionic compounds. And ionic compounds are generally made of what two types of elements? And metals. But metals get written first. And the reason why is because metals will end up having a positive charge and the non-metals are negative. So you're always going to write positive before negative. The base unit of an ionic compound is called a formula unit. So molecular compounds are made of molecules. Formula units make up ionic compounds. So what we're going to do is we're going to start naming. All right. Some of these are going to be a lot easier than naming the moleculars, and you're going to see why in just a second. But then it gets a little bit harder. So in the beginning it's really easy, and then it gets a little bit harder. Okay? So it says write the name for each of the following. These have to be fixed charge metals. We're not going to talk about the variable charge ones until the next part, the next lesson. Okay? So we're going to try to write the names of these. If it's a fixed charge, what it says is write the name of the metal, which is the cation. Write the name of the non-metal, which is the anion. The only thing is, you have to change the ending to "ide." Okay? IDE. We're going to start at the very back of the room, and we're just going to make our way up. So back corner, Ca is called what element? And what is Cl? Chlor, and then change the ending to chloride. Awesome. Done. That's it. Okay? There are no prefixes on these because they're ionic. So you don't use any prefixes when you're naming ionics. And that's it. That part's done. Okay, next person. NaBr. What do you think that is then? Sodium bromide. All set. Zinc oxide. Perfect. Okay. So now you're probably wondering, how can that be? Because how are you supposed to know that it's a 3 and a 2 if they're just saying zinc phosphide? Well, when we did moleculars, if it was something like carbon dioxide, you knew it was 1 carbon and 2 oxygens. The coolest thing about the ionics is, if they have a fixed charge, there's only one way that they will bond. Okay? So we're going to talk oxidation numbers for just a minute here. The thing is that elements, let me go to the periodic table, and we said that sodium's a +1 and like magnesium's a +2. If it's fixed, now it starts off being neutral in nature. So if you found a piece of magnesium, it would be neutral. But when it bonds, magnesium will only lose 2 electrons. Otherwise, it will not bond. So we were talking about Club Chem, and we said that sodium was going to lose 1 electron, and chlorine walked in the door, and she wanted to gain 1 electron on chlorine. So chlorine, you should have a -1 on there. That creates a bond, and they're now neutral. So the compounds are always going to be neutral. And the one that is losing the electrons is typically the metal, and the one that's gaining the electrons is going to be the non-metal. So the question is, how are we supposed to figure out what the formula is then on here? I'm going to tell you that there is only one formula that would exist between these. And so what we're going to do is we're going to work backwards now, and we're going to see how this works. What you're going to do is, you're going to write the elements with their charges above, okay? And then I change this. It's going to be crisscross absolute reduce. Everybody say it. Ready? Crisscross absolute reduce. What I mean by absolute is, so make sure that you change this, is you're going to write the absolute value. What is the absolute value? Only positive, no negatives. Okay? Everything becomes positive. So if it's negative, make it positive. So what we're going to do is we're going to crisscross our charges, but we're going to take the absolute value of it because the number that's written down on the bottom tells you how many atoms. The charge will get written on top, and the number of atoms will get written on the bottom. So let's try this and see what happens. So the first one that it says is calcium chloride. So I'm going to do the first one, and then I'll continue with having people help me. So calcium, I'm going to find calcium on the periodic table. And calcium's charge on the periodic table says what? 2. Everybody, +2. Now we're going to find chlorine on the periodic table. And remember, what we had said was we're going to use the 0, -1, -2, -3, and -4. So if it's chlorine, what charge are we using? -1. Even though there are these other numbers there, we are not using those numbers. We're just going to use the -1. So we're going to consider this to be fixed. Okay? So we're not going to have different numbers, those different numbers on there. So calcium's going to be a 2 or a +2, whatever you want to write. I'm going to write Cl, and then up here I'm going to write a -1 or a negative. These are the charges. The charges go on top, okay? What's going to happen now is I'm going to crisscross them, and then I'm going to explain why this works. So the 1 is going to come down here, and the 2 is going to go right there. So what this formula becomes is, you don't have to include the charges, this tells you your number of atoms. That's the number of atoms that exists. So this would be CaCl2 is the correct formula. So let's talk Club Chem for a minute, okay? Calcium's having a good time at the club. He's dancing. He's got his hat on backwards, having a nice time. And chlorine walks in the door, okay? Calcium will only bond if calcium can lose how many electrons? 2, okay? Chlorine wants how many electrons? 1. So chlorine comes in and calcium is like, hey chlorine, you're looking good. And chlorine's like, oh hey calcium. And he's like, I have 2 electrons. Will you take 2 electrons? And she's like, no. Why can't she take 2? Because if chlorine takes 2 electrons, then instead of having 18 electrons, now it has 19 electrons, and that's not stable anymore. They want to have a stable electron configuration like the noble gases. What makes them special is what's full. What do we say was full?
Energy level.
The energy level. Awesome. If the electrons fill the entire energy level like they do for the noble gases, so like an S2 and a P6, that makes it a full energy level and it's very stable and it doesn't want to change that. So chlorine doesn't want to gain any more than 1, okay? So guess what chlorine does? Yeah, brings her twin. Chlorine brings her twin. So now what happens is we've got 2 chlorines. So and now calcium's like, that's good because calcium can give 1 electron to one chlorine, 1 electron to the other, and now they're neutral. So one loses 2 electrons and then those other 2 each gain 1. So now it's a bond that's created, okay? They're dancing, they're having a good time, right? So that's the bond that's happening in here. All right, so next one, sodium. So find sodium and tell me what the charge is, please. What's the symbol and the charge of sodium?
Na1.
Perfect. Okay, next person. What is this bromide?
Br -1.
Perfect. Awesome. A 1 and a -1. The last part of this is it's crisscross absolute reduce. We're going to take the absolute value of these, which is a 1 and a 1. When I say crisscross, we're going to cross them opposite, so a 1 and a 1. But it's already reduced. A 1 and a 1 is fine. Your formula is just going to be NaBr, and you're done. Let's do the next one. What is strontium, please?
Sr and then 2.
Perfect. And next person, what's nitride?
N-3.
Very good. And -3. Next person. So what would you do if you've got a 2 and a 3? What are you going to crisscross then? You're going to get Sr3 and N2. Perfect. Awesome. So when I say absolute, that's just the absolute value. That's what that means. Okay, so take the absolute value of it when you crisscross it. Let me show you this one for just a second. Okay, because you're probably wondering, why is it Sr3N2? You don't have to draw this. Okay, I'm just going to draw something for you. So strontium comes to the club. And strontium wants to give away 2 electrons. It wants to give away 2 electrons. Nitrogen comes walking in, so here's strontium with his backwards cap, okay? Nitrogen comes in, and nitrogen is our cute girl here, okay? And she actually wants to accept 3 electrons. So she wants to accept 1, 2, 3 electrons is what nitrogen wants. What's wrong with this? Strontium doesn't have enough. So guess what strontium does? You can't change the elements. Guess what strontium's going to do? He's going to go and get his twin. So we get another strontium. Fine. This one wants to also give away 2 so that he can become more stable. But now we've got 4 and 3. So that's still not working. So now what happens? She's going to get another twin. Okay? So now nitrogen comes in. Here's our nitrogen girl right here. And she wants 3 electrons also. Still not not working. What's wrong? What do we do now? One more strontium, and now if we do one more strontium, giving 2 electrons each, now we've got 6 being given, and how many being taken? 6. It has to be electrically neutral in order to form a compound. Otherwise, it does not exist in nature. Okay? It will not exist in nature. Doesn't happen. Those 2 elements will not come together unless they come together in this way. So you would never have SR2N. It's not going to happen. Okay? You can have SR3. So the way you would write this then would be, you would write it as SR3 and 2, because this number down here tells you your number of atoms. And when you write a formula, you don't have to show the charge. You only have to show the number of atoms that you have in your compound. Good? Okay, so let's go back up and let's try these other 3. They cancel out. You can either cross them first and then cancel out, or you can just cancel them out up there and you're done. It's just Z and O. So if you're reducing and it's like a 4 and a 2, then let's say that you had X4, Y2. What would you do? You would divide both of them by 2. And so that would be gone. You would make that a 1. And this one would be a 2. So that's how you end up doing the reducing. Okay? All right. So, and that's the end of the